All right, guys, what we're looking at here is finding the Maclaurin expansion of f of x equals e to the x. Just a heads up, you're not going to be asked to do that exact problem. In fact, you'll be expected to know what the Maclaurin expansion is of e to the x. We're just going to walk through it quickly, and then we're going to use that to try to find some more complex, the Maclaurin expansion of some more complex functions. So remember, we start out with the function, find its respective derivatives, and then evaluate at x equals 0. Again, it's at x equals 0 because it's the Maclaurin expansion. You'll see sometimes we do a Taylor expansion, and that will be at different values of x. So 0th term, first, second, third, fourth, and of course it goes on forever, right? It's an infinite series that should estimate this. So the function is just plain old e to the x, right? Because that's f. F prime is e to the x. F double prime, again, e to the x. Third derivative, e to the x. And then the fourth derivative is also e to the x, right? So if we were to evaluate each of those at x equals 0, we would get 1 for every single one of them, right? Because, of course, e to the 0 is 1. So we now have enough to try to build our Taylor coefficients, and then, in fact, our power series that will represent the function e to the x. So our 0th term will be 1 over 0 factorial times x to the 0. Our first term is 1 over 1 factorial times x to the first. And then you can see the pattern is very easy to pick up on with e to the x. We've got 1 over 3 factorial, x to the third power. I'll just write the fourth term now that I have it. Pretty straightforward. Of course, clean it up. This is 1 over 1 times 1. So that's just 1. 1 over 1 factorial. And we just get x. And then we'll say x squared over 2 factorial plus x cubed over 3 factorial plus x to the fourth, 4 factorial, and so on forever. That should be equal to e to the x, right? This infinite series actually converges to e to the x. So if I want to write this out, right, I've got, let's see, it's going from 0 to infinity. And each of these looks like x to the k, right? X to the k over k factorial. So this infinite series, it's a Maclaurin expansion of the function e to the x, will be exactly equal to, it will converge to e to the x.